Hello students, how are you? We are going to start next chapter for the second chapter of decision making. The name is planning with limiting factor. Okay, so actually this topic is also included in MA2 the basic paper, but obviously if you haven't done that paper, no issue, we'll do it from the basic level. So what is a limiting factor? What is a limiting factor? Actually, there are some factors in the organization that are limiting your activity, that are limiting your activity. So factors that are limiting your organization's activities. Like, for example, if you are in the production department, for example, you are in the production department. So obviously you need material, you need labor, you need machines, and also you have to see the sales demand. If there is a demand of sales, then you have to make that product. So for example, you are having the labor, uh, like uh, like a lot of labor hours available, and you can easily do the production. You are having the machine, you are having the sales demand. You know that if you will make the product, it will be sold easily. So if material quantity is not available as you need, so obviously it's the limiting factor. For example, you are having a lot of material, but you are not having the labor hours. In that case, labor hours are the limiting factor because they are limiting your activity. You want to make more, you want to produce more units, but due to the lack of labor hours, due to the shortage of labor hours, you are not able to produce the material as per your demand, as per your sales demand. So there are some limiting factors in the organization that are like limiting your activity, and it's your duty, it's your responsibility that with that limiting factor you have to perform best. Because if you are in the good scenario and you are having everything okay, then obviously you can earn more. But this chapter is basically the proper planning with limiting factor, means that if you are having any shortage of material, labor, machine hours, or sales demand, you have to fight with that, you have to face that, and you have to do the best planning, you have to perform the best activities so that you can earn more profit. So actually the motive is to perform best, or to earn best profit, perform best while having shortage of resources. Shortage of resources means that if any resource is in shortage of resources. Okay. So we have to perform best, we have to generate best profit while having the shortage of resources. So for that, we have the question. I'm directly starting from the question. Why I'm directly starting? Because we'll understand the main topic in this question as well. So we'll do the practice plus we'll understand the topic with this question. So question says that X Limited makes three products F, A, B, and C, for which unit cost, machine hours, and selling price are as follows. So they have given you all the data for the materials, for the products A, B, and C. Sales demand for the period is as follows. Sales demand is also given for A, B, C, like they are the units. These are the units: 4,000, 6,000, and 6,000. Company policy is to produce minimum of 1,000 units of A. So it's a company policy. You have to make minimum 1,000 units. We'll see that what's the issue of this 1,000 units in the question. The supply of material in the period is unlimited. It means that material is not the limiting factor. It's unlimited. The supply of material, you can purchase like unlimited material, and you that can obviously meet your sales demand. So it's not the limiting factor. But machine hours are limited to 200,000 and direct labors are limited to 5,000. There is a limit in machine hours and direct labor hours, but we'll not say that these both are limiting factor. We'll first identify that whether machine or labor, which is limiting factor. Why we have to identify? Maybe like you have seen that machine hours are available 200,000. Machine hours are available 200,000. Maybe you need 190,000. Maybe you need 190,000. So in that case, it's not a limiting factor. Limiting factor arises when you need more and you're having less. Like for example, labor hours. Assuming that you need 6,000 labor hours, but you have 5,000. In that case, it's a limiting factor. So this is the scenario of the question we are doing is of the single limiting factor. First, we are doing the topic single limiting factor in the question. Then we'll do the topic with the multi limiting factors as well. So with the single limiting factor, out of these both labor and machine hours, will be having one limiting factor, and using that limiting factor, we'll do the complete question. First, we have to identify that. So this is the question. Now, what is required? Obviously, it's written, but I'm not telling you the requirement right now. We'll do the proper steps one by one and we'll understand the concept with the question as well, right? Let's start the question. Okay. So, step number one is to identify limiting factor. Identify limiting factor. So, first thing we have to do to identify the limiting factor, as we have discussed in the question, we have two types of factors that are limited. So, we have to identify which one is limiting factor, like which one is available less and required more. So, first we'll see according to machine hours. So I'm doing the calculation according to machine hours, whether it is a limiting factor or not. Okay, so according to machine hours, let us start. We have how many products? Three products, A, B, and C. We have A, B, and C. Three products we are having. Three products we are having, A, B, and C. First thing we have to do is to see that how much machine hour is required, how much machine hours are required for A, B, and C. Any machine hours per unit means machine hours per unit. So machine hours per unit, this is given that 10 hours of machines are required on A, 12 hours on B, 14 hours on C. So it's like on A, it's on A, it's 10 hours. On B, it's 12 hours. And on C, it's 14 hours. Why we have written that? So that we can like calculate the total machine hours required for all of these products that the business is producing. So these are the machine hours per unit. These are the machine hours per unit. Let's multiply it with the units to calculate the total hours required, because it's machine hours per unit of A, B, and C. So it's written here the products, the number, units of the products. So let us multiply it with the units. Units are like 4,000, 6,000, and 6,000. And multiply here and calculate total machine hours. So 4,000 into 10, 40,000. 6,000 into 12, it's 72,000. And 6,000 into 14, it's 84,000. So these are the total machine hours required by A, B, and C. Now we'll add all of them to calculate machine hours required. Machine hours required. So 84,000 plus 72,000 plus 40,000, it will be 196,000. Here we come to know that total machine hours required were 196,000. Total machine hours required were 196,000. But what hours are available? How many hours are available? This is given in the question that 200,000 hours are available. 200,000 hours are available. If you are requiring like just 196,000 hours and available hours are more, that were like 200,000. Obviously, this is not a limiting factor. This is not a limiting factor. You are like, you just need 196,000 and you have 200,000 more hours available. So if you are having more resource, that's not the limiting factor. From here we conclude that labor is the limiting factor, because in this question only two factors were in limit. But let us calculate for labor as well. Let us calculate for labor as well, whether it's the limiting factor or not. We are confirmed that labor, if material is not, then it's confirmed that labor is the limiting factor. But let's calculate so that you can do proper questions after understanding. So labor hours, according to labor hours, I am first writing how many labor hours per unit is required. So A, B, and C, it's written for A. Labor hours, it's written 7.5 is the hour. Total cost, because it's the dollar sign, total $9 is being used on 1 unit of A. But it's total dollar per unit. You need labor hours per unit, not the labor cost per unit. So labor hours, it's given 1.2 hours, 0.8 hours, and 0.4 hours for A, B, and C respectively. So labor hours per unit 1.2 under A, 0.8, 0.4. 1.2, 0.8, and 0.4. These are labor hours per unit. These are labor hours per unit. Again, the same concept as we have done in machine. Multiply with the units. Units are 4,000 for the product A, 6,000 for the product B, and 6,000 for the product C. Let's calculate it. Okay, it's 4,800 labor hours here, 4,800 here, and 2,400 here. For A, B, and C, total labor hours required, we have calculated. Just add them. It will be like the labor hours we require for production are 12,000 hours. 12,000 hours. But available labor hours, if you see, they are just 5,000. You need more labor hours, like 12,000, far ahead from the available labor hours that are like 5,000. So this is the limiting factor. This is the limiting factor. From here we can confirm that labor hours are the limiting factor. Now sometimes they ask you the difference between required and available. So remember this point, that the difference between required hours and available hours is known as shortfall. Sometimes they ask in MCQ what is shortfall. So what you have to do, just take the difference between required and available of the limiting factor. See, it's not the shortfall here. You can't say that 4,000 difference is a shortfall. Shortfall is only for the limiting factor. The factor that is not a limiting factor, there will be no shortfall for that, right? So it can be asked in the question. So from step one, we'll only identify the limiting factor, and we come to know that labor hours are the limiting factor. This is the step you have to calculate properly. Sometimes in some questions, they give you directly limiting factor and you have to start from step two directly. Sometimes they directly tell that labor hours are the limiting factor, and now you don't need to do the step one. Okay, let's go towards step two. Step 2 is limiting factor per unit. Step 2 is limiting factor per unit. Step 2 is limiting factor per unit. Okay, okay. Limiting factor per unit means you have to write limiting factor per unit for all of the product. And you know that limiting factor per unit, and you know that limiting factor per unit in this question is actually labor hours per unit. Limiting factor is labor hours. Obviously, in step one, we have identified that. So labor hours per unit we have to write for A, B, and C. Simply just take from the question right here. Simply just take from the question, and we know that labor hours per unit we already have seen 1.2, 0.8, and 0.4. You can also take from step one as well, like 1.2, 0.8, 0.4. Just right here 1.2, 0.8, and 0.4. Step 2 is done. Step 2 is done. No calculation in step 2. Just take from the question, write the value. Question is done. Question is done. Labor hours per unit you have written. Now the third step is contribution per unit. Okay, why we are doing this step? Again, actually, first thing we have to identify limiting factor. Actually, we have to perform best. Perform best, like we have to generate best contribution while having the shortage of resources. So that's why first we'll calculate the limiting factor, then we'll write step 2 limiting factor per unit, because we'll calculate the best contribution we can earn with this limiting factor. With this limiting factor, which one? Labor hours. With this labor hours as a shortage, as a like resource that is short in the business. After that, obviously, with this shortage we have to earn very good best contribution we have to earn. For that we have to do these steps as a calculation. So the second step, limiting factor per unit, we have calculated. Third step you have to do is contribution per unit. You have to calculate the contribution per unit. Third step, you have to calculate contribution per unit for all of them. And I think contribution is given here. See, if contribution is not given, it's like selling price minus all variable cost. Just deduct, like for example, there is selling price here. Just deduct variable overheads, direct wages, direct material. So you will get contribution. So contribution is simply selling price minus all variable cost. 6, 5, and 4. I'm writing here 6, 5, and 4. 6, 5, and 4. This step is done. So step 2, simple, take limiting factor, write it. Step 3, simple, take contribution per unit, write it. Fourth step is contribution per limiting factor. First step was identify limiting factor. Second, limiting factor per unit. Third, limiting contribution per unit. Fourth step is contribution per limiting factor. It can be calculated easily. How? You have answers of step 3 contribution per unit and answers of step 2 limiting factor per unit. Just divide contribution per unit on limiting factor per unit answers. You will get contribution per limiting factor. Like just divide this 6 with over 1 over 1.2. 6 divided by 1.2, it will be like 5. Then 5 divided by 0.8, it will be 6.25. It will be 6.25. And 4 divided by zero point 0.4, it will be 10. It will be 10. It will be 10. Okay, wait. Now we have calculated this contribution per limiting factor. That we have just divided the step 3 answers with step 2 answers. Actually, this contribution per limiting factor, what it is indicating, what it is saying, this is saying that the limit, according to one limiting factor, you are earning the contribution of, for example, 5, just like in the case of A. For per limiting factor, you are earning 5. Like if you are, limiting factor is labor hour. If you are, like I'm just elaborating the concept of contribution per limiting factor. If you are using one labor hour on product A, it is giving you 5 contribution. Contribution is the earning. Contribution is obviously sales minus variable cost. It's the earning. Contribution is earning, and we want to obviously earn more contribution, more earning, right? So for 1 hour used on product A, you are earning 5. For 1 hour, like on B, you are earning 6.25. And for one labor hour, if you are that using that labor hour on C, that's giving you $10. So obviously, which product you will prefer to make first? Because obviously you are having the limited labor hours. So you know that now you can't make all the units. You can't meet the demand because you have less labor hours. Like you need 12,000 complete labor hours, but you don't have. So you need you have to manage in 5,000 hours. Now you know that if you will invest all the labor hours in product A, maybe A is not generating the good contribution and you are in loss now. Loss in a sense, like for example, if it's giving you less contribution as compared to C. So you must use that labor hours to produce C first. Like in this scenario, if you do the ranking, basically step 5 is the ranking that will be obviously on the based on contribution per limiting factor. If you see the best earning you are getting from these products A, B, and C, your best earning you are getting from C, like 10 per limiting factor. So you will prefer to produce C first. This is the planning. That is actually the planning with limiting factor, because first you know what's the limiting factor, it's labor hours. Then you calculated limiting factor and contribution per limiting factor. Now you know that this is the earning you are getting per limiting factor for each product. And after that, after the answers, we come to know that C is generating $10 per labor hour, means per limiting factor, and other products are generating less income. So you will not rank first A or B, you will rank first product C. After product C, you will rank, after product C, you will rank second, at second point, you will rank B. And at last, you will produce A. This is basically the production plan, that which product you have to make first. Obviously, that product you have to make first, which is generating you more income, which is giving you more contribution. And here, C is giving you more, like 10 contribution, and AB is giving like 6.25 and 5. So you'll rank accordingly. Actually, this is the planning of limiting factor. Step 5, ranking has been done till this point. We have 2 more steps as well, because we have to calculate the maximum contribution as well. Still, step 5, just revise the concept. First, identify limiting factor. It can be machine hours, material quantity, labor hours. You have to identify that. Sometimes it's given in the question. Second, limiting factor per unit. Just write that limiting factor per unit, then write contribution per unit, and just divide step 3 answer divide by divide on step 2 answer. You will get contribution per limiting factor. Now you know that which product is giving the contribution per limiting factor how much, and from that values you have to do the ranking. The product with the higher limiting contribution per limiting factor, you'll rank first, and then you will rank accordingly. Now, step 6 is actually optimum production plan. Here you will make the plan. Actually, this is a step you are starting the plan, like which product we have to make first. And step 6, now we have to make the plan ourselves. We have to make the plan ourselves. Now in this step you have to do the working. Like here I have to do the working here. Here I am doing the working. And the product, obviously, why I have written ABC here, I'll tell you that. But on this side, you have to do first the working. You have to do the working first. Okay. So if you see how to make the best plan, first you have to see you what is the limiting factor. Limiting factor was labors and how much labor hours were available. How many labor hours were available? If you see, available labor hours are 5,000 hours. You should write 5,000 here. You have to write 5,000 labor hours here. Now we'll see one by one that how much labor hours every unit will consume according to ranking. So according to ranking, which product you will make first? You have total 5,000 hours and that is a short. And that is short. I know that 12,000 hours are needed, but you are having 5,000. So according to ranking, which product you will make first? Obviously, you will say that will make first C. You will say that according to ranking will make first C. And if it's a normal scenario, like normal question, I would have written here C. But in the question, if you remember, there was written company policy is to produce minimum of 1,000 of product A. If there was this line was not mentioned in the question, I would have start from the C. First, I will make the C. But if in the question there is like written, we have the policy of the minimum units of this, even A is coming at the end in ranking. Even A is not like giving you good contribution, but company policy is to make that product first. So you have to make it first. So first you will make how many units of A? 1,000, not all. Actually, total units of product A were 4,000. Company policy is to make 1,000 unit of A. So first you will go through this A, product A, and then we'll do the ranking according to the step 5 we have done. So for first product A that we have to make, if you see how many units you have to produce, 1,000. I'm writing here 1,000. I'm writing here 1,000 units we have to produce. Okay. Multiply. If you see, now you have to see that for these 1,000 units, how many labor hours will be required? For these 1,000 units, how much labor hours are required? So if you go to the labor hours, see that step 2. So product A requires 1.2 hours of labor. Product A needs 1.2 hours of labor. So you'll write here 1,000 into 1.2. It means that A will take 1,200 hours. A will take 1,200 hours. A will take 1,200 hours of labor. See, as a normal scenario, I know C is very good product. We have to rank it first, make it first. And as much as labor hours we can invest on C, we will invest because C is giving you contribution, good contribution. It's the good planning. But if there is a policy of a company, we can't do anything. In that scenario you have to utilize the labor hours or machine hours or the limiting factor for that product first, which the company policy says that make it first. So 5,000 minus, if you see, out of this 5,000, 1,200 hours are being consumed by A. Remaining you have just 3,800 hours. Remaining you have just 3,800 hours because out of 5,000, 1,200 hours A has consumed. So you will write here in the plan that we have already made, we can make 1,000 units. We can make 1,000 units. You have mentioned here. You have mentioned here A can be made 1,000 units. Now the second point. Second point. If you see the second point, now there is no other policy that make B or C. Now we'll focus on the ranking. Now we'll focus on the ranking. According to ranking, which product we have to make first? C. We have to make first C. So now I will write here C. How many units of C we have to produce in total? 6,000. 6,000. So I will write here 6,000 multiply. How many hours C is taking per unit? 0.4. So it's 0.4. It's like 2,400. So we know that out of 3,800 hours, we can utilize 2,400 hours. Out of 3,800 hours, we can utilize 2,400 hours. And congratulations, Congratulations. If you are investing like 2400 hours on C, you can complete its sales demand. You can make all 6000 units the product that is golden product for you, generating more profit for you. So you can say here, you can write here that C is making, like we can make 6,000 units in complete for C. Still labor hours are available. How much? Still labor hours are available. How much? 1400 hours. 1400 hours still available. Now, after that, we have to make B. After that, we have to make B. Okay, let's see for the product B. If we see B has 6,000 units, B have 6,000 units. I'm writing here 6,000 units. Multiply. 1 unit of B requires 0.8 of labor, 0.8 hours of labor. But if you are doing 6,000 into 0.8, it will be 4,800. But you only have 1400 hours now available, so you can't you can't take 4800 hours, as you are not having it, you are only having 1400 hours, and B wants 4800 hours to be produced completely. So here you are stuck. Here you are stuck. Now you have to take the decision that how many units of product B can be made. This is confirmed that total 6000 of B can't be produced. Simply. Like they need 4800 hours and you have only 1400 hours. So here there is a technique that what you have to do, the hours you are left with 1400, just write here 1400 hours, just write here 1400 hours divided by labor hours per unit for B. It is 0.8. So if I do 1400 divided by 0.8, it will be 1750. It means we can only make 1750 units of B. Let me prove. Let me prove. See, 1750 units multiply how many labor hours one unit of B is taking? 0.8. Multiply it with 0.8. You will get answer 1400. You will get answer 1400. So you can utilize 1400. You can utilize 1400 hours for B, but complete B will not be produced. Like complete 600,000 units will not be produced, only 1750 units. So for B, we'll write here that total units are not produced, only 1750 units are produced. But where is the planning factor? Actually, we have made the best plan. How? Because we have first calculated contribution per limiting factor to identify that what is the first product on which we consume this labor hour, on which we for which we like uh, contribute these labor hours, because we already have the labor hours as a shortage, so we need to invest, we need to use that labor hours for that product first, that is giving you good income, good contribution, good profits. So that's why our ranking was C, B, and A. But there was a policy that you have to make 1000 units of A. It's must. So we have, like in that case, we have to write A first. But if it was not the case, like A, there's no policy, then we have to do like C, B, and A. Here it's like A, C, and B. Like A 1000, C all units complete, and B like only 1750 units. Now next step, last step. Here we have done best plan. This is the best plan the company can do. Like it's the best plan according to which company can earn the best profit. If you are changing this plan, like you are making B first and C afterwards, you will not earn more profit. So next plan is like maximum contribution. The last step is maximum contribution. Last step is maximum contribution. Okay, so this for this maximum contribution, what you have to do, you know that A, how many units of A you can produce? 1000. B, only 1750, and C, 6000. And you need to calculate maximum contribution, just multiply it with the contribution per unit. Simple. That's not the tricky. Simple, you have to calculate maximum contribution. You have a best plan. Take that best plan, means units, multiply with the relevant contribution per unit, and its contribution per unit is given here in step 3. 6, 5, and 4. 6, 5, and 4. So it will be 6000. 1750 into 5, it will be 8750, and it will be 24,000. You will get maximum contribution. 38750. 24,000 plus 8750 plus 6,000. 38750. This is the best profit you can earn in this scenario. I am saying if you like rearrange the unit products, first make B and making C afterwards, your profit will get lower. And in the case if A, because it was a policy, and if it was not a policy, A would have been obviously produced at last. Then the ranking will be like C, B, and A at the last. In that scenario, we'll able to earn more because that was the best situation. But it was a company policy to make A 1,000 unit first, so we have made that. But if you are changing the plan, like making here, like A is a policy, okay. After that, if you are making B first and C afterwards, you will never get the maximum contribution like this contribution. So this is the actually planning of limiting factor, that if you are having any scarce resource like shortage in any of the resource, you have to plan well, because with that shortage of resource, you have to perform best, and it's only possible if you are understanding this concept. You apply this concept in companies. When you are facing the limiting factor, do the calculation using contribution per limiting factor for ranking, produce the units according to that, and you will get the maximum contribution. If you are changing the plan, obviously you are not focusing on optimum point, and you can't get the maximum contribution. Till here we are done with the limiting factor, where there was a single limiting factor in the question, but let me know you let wait but let you know one thing, that there is something, an other level, next level to in this chapter, that is several limiting factors. Several means more than one limiting factor if there is in the question, how we have to do that. So the topic for several limiting factor is known as linear programming. Topic of several limiting factor is known as linear programming. Okay, let me tell you one thing here. One good news for you. This is again the topic of graph. This is again the topic of graph, as we have done in break even. So there I have told you that there will be no graph question in the exam. Same here, there will be no graph question. You don't have to make the diagram or make the graph for that. But one thing that is important, you have to understand that. Again, the same point. You have to understand that. So to understand that, I'll do one question for you, and you have to understand it. Just for understanding purpose, I am going to do this complete calculation for you. So this is the topic we are going to start, is several limiting factors, how we have to deal. In the single limiting factor, we have to do these 7 steps to calculate best contribution, maximum contribution. But if it's a scenario of this case, because here, no doubt, you don't have to make the graph, but many questions other than graph can be made from this topic. I'll tell you how. I'll tell you how and how it is tested, how it will come in MCQs or CR. I will tell you in the practice as well, but it's important, very important topic for you. Okay, so let's start in 2 minutes. Let's start. Okay, so now we are going to start linear programming. Linear programming, as we have discussed, that for several limiting factor we have to do that, do this topic, and obviously again the concept is still of the single limiting factor, where we have studied that with that limiting factor we have to perform well. So linear programming, obviously, the question is given here: the company produces two products in three departments. Details are shown below regarding the time per unit required in each department, the available hours in each department, and contribution per unit of each department. So there, he has mentioned that you have given with the time per unit required in each department for the products. Then they have given the total available hours. Like, see, there are two products, product X and product Y, and now they have given available hours as well. That hours available, and we'll see what we have to do. So there are three departments: Department A, B, and C. If you see, they've given you that in Department A, X needs 8 hours and Y needs 10 hours. In Department B, X needs 4 hours and Y 10 hours. C, 12 hours for X and 6 hours for Y. If you see that available hours are also given, available hours are also given. So it means they can be the limiting factor, they can be the limiting factor. So the question with several limiting factors, obviously we have to do, not, we don't have to do like as we have done in single limiting factor, because there are available hours more. I know that all of these are not limiting factor, but obviously amongst all these limiting factors, there will be some limiting factors. There will be some limiting factors. So let's see the question. After that, it's given contribution per unit as well for both X and Y. And there is also written there is unlimited demand for product X. It means that you, how much you can, if you are making like unlimited units, means you are making a lot of units, it can be sold easily. Why? Because it's written the demand is unlimited. When the demand is unlimited, it means that you don't need to be worried about production. As much units you can produce, you can, because it can be sold easily. But demand for product Y is limited to 600 units per annum. So it means that demand for product Y is can also be the limiting factor, is also the limiting factor here. So in this question, actually you have department A as limiting factor, as a shortage, because available hours are 11,000. Department B 9,000 hours available. Department C means there is a limit, means there is a limit in this scenario A, B and C. And one limiting factor also arises here, that is written like product Y demand, that is 600 units per annum. So let's start the question. First of all, in several limiting factor, when you are doing the linear programming, again I'm saying you, these workings I am telling you for understanding, it will not come in exam. In exam, what it will come, we'll do in practice. We'll do in practice, and accordingly exam will, in the exam you will be tested when you'll do the Kaplan kit, and we'll do the CR long questions for that. So several limiting factor. First step you have is define variables. Define variables. So what is variables? What is variables? Actually, the products you are having, like for example X and Y, you consider these products as variables. Variables are the products you are considering. So I am writing here X and Y are variable. I am writing here X and Y are variable. I am writing here that X and Y are variable. X and Y are variable, right? This is the first step. Simple. Take the product and write its name. After that, define and formulate objective function. If you understand the line, it's written define and formulate. Formulate means make a formula of objective function. Objective function means what is your objective? Actually, our objective in this question is to earn maximum, contribution, regardless of having any limiting factor. We have to earn more. We have to earn as much as we can earn. We have to earn with, obviously with the also facing the limiting factor in the question, we have to earn more. So for that we have we have the objective to earn more. Earn more what? Earn more contribution, as we have done in the last scenario. So here our objective is to earn more contribution, or you can say you have to earn maximum contribution while having limiting factor, while having the shortage of resources. So you have to make the formula of that objective function. Now we know we have the objective of maximum contribution, and contribution is given here. So we have to take this contribution in every question. We have to take this contribution and make a formula. How? See, contribution I am indicating through C. C is equal to, C means contribution is equal to, if you see the contribution per unit, it's 4. And it's, if you see it, the 4 contribution of the X, 4 contribution is of the X product. So I'm writing here 4X plus, for Y the contribution is 8y, 4X plus 8y. So this is the formula of objective function, that will take the contribution values from the question, and we will make the formula like C means contribution is equal to the contribution of the product. Write the contribution into X, like 4X plus 8y. For example, there are 4 products, so we'll write accordingly. But in this question, in this topic, obviously you will always be tested with the 2 products, not 3, 4 or 5, like not like that. You will be tested like only 2 products, but limiting factor will be several. Limiting factor will be more, like here you see that there are limits in these 3 departments, plus there is a limit in the demand as well. So there are 4 limiting factors, 4 factors that are limiting, that are in the limit. So actually for the limiting factor, there can be like 4, 5, 6 and so on. But for the product, you will be given only two products in this scenario. Two products in this scenario as it's given. So formula I made is 4x plus 8y. First was define variable. Second, define and formulate objective function. Define and formulate objective function. Okay. Now, third point, formulate constraints. Formulate constraints. Constraints are actually the factor that is in limit, the factor that is in limit. So we have to formulate that constant. We have to formulate that constants. Now we know that how many factors we are having in limit. Department A, yes, because there are some available hours. So it means there is a limit of 11,000. Department B, 9,000. Department C, 12,000. And there is one limit also in demand of product Y. So demand for product Y is also the limit. So we have to make the formula for it. How we will make that formula? How we will make that formula? It's very easy. It's very easy. If you see, if you see here in the question, for department A, you need 8 hours on X, 10 hours on Y. 8 hours on X, 10 hours on Y, and your available hours are 11,000. Your available hours are 11,000. So formula you will make is 8x 8x plus 10y 8x plus 10y. Okay, 8x plus 10y. Now 8x plus 10y. Further, what we'll write? What we'll write? We will write is less than or equal to this 11,000. What it means? 11,000 means the resource available. It means that in department A, 8 hours will required by X product plus 10 hours will required by Y product. We can use complete 11,000 hours. We can use complete 11,000 hours or less. We can't use more. So that's why I have made the sign of less than or equal to. Less than or equal to means that when we'll make the product in department A, when the product X and Y are gone and are processed and are produced through the department A, only the available hours in that department is 11,000. So we can utilize complete 11,000 or less, not more, because we are not having more. So that's why we have to make the formula. Second formula, for formula, just think in your mind. What will be the second formula for department B? You will think right. You will think right. Just think. Are you thinking this one? 4x plus 10y is less than or equal to 9,000. If you are thinking this formula, you are right. You are right. Because 4x here plus 10y is less than or equal to 9,000. You can use 9,000 or less. Department C, 12x plus 6y is less than or equal to 12,000. Is less than or equal to 12,000. 12x plus 6y is less than or equal to 12,000. You can utilize 12,000 hours or less. And also there is one another constant. Constant means there is another limit, the demand limit for y. So for y, you can only sell, you can only make, basically you can only produce 600 units. So I will write here y can be made less than or equal to 600 units. Mean y can't be made more than 600 because you don't have a sales demand. You don't have the sales demand. You don't have the sales demand of more than 600 units. So you will write here y is less than or equal to 600 units, means you can't sell more than 600, sorry, 600. You can sell 600 or less. So these are the limits, and we got in the question and we have formulated that. So this formula is must. You must have to like you can say learn it, that how this formula is made. You have to learn it, that how this formula is made. So first step, define variables. Second step, define and formulate objective function. Third step, formulate all the constants. Sometimes it's 3 constants, sometimes 4, sometimes 5. The constants you are seeing in the question, you have to write every constant. You have to make the formula of every situation, every constant. Okay, now there is a fourth step. In the fourth step, the third step we have done. Fourth step, what you have to do, you have to take all these formulas in this box. I've made 4 boxes. So first I will take department A box, department A. Then I will do working for department B here. Then department C, and then the demand, because I was having 4 constant, 3 were related to department and 1 was related to demand. First formula was in of department A was 8x plus 10y. Now I have to add here equal to 11,000, not less than or equal to. This was just to understand the concept that it will be utilized 11,000 or less. That's why I've written less than or equal to. Here you can write equal to, simple. Department B formula is 4x plus 10y equal to 9,000. Department C, 12x plus 6y is equal to 12,000. And here y equal to 600. Like y can be solved 600, not more. Right? Now, first formula you are having 8x plus 10y is equal to 11,000. Here what you have to do in step 4. Actually, in step 4, you just have to consider in every scenario that if, for example, you are selling 2 products, X and Y. For example, I am considering here that if we are making no units of X, like X is 0. If X is 0, like you are not utilizing the time on the hours on X, you are not making any X. So it means X is 0. In that scenario, what will be, how many units of Y will be produced? So the formula you are given with is 8x plus 10y. So what you will do, now you know that 8 into X is 0 now. In case of 0, X is equal to 0, just I am going to see that what units of Y will be produced. So plus 10y equal to 11,000. Y is equal to 8 into 0 means 0. And here 10y is 10 is multiplying here. It will be divided on other side. So 11,000 divided by 10. So it means Y can be produced only 1100 units. In scenario of if X is not being produced, in the scenario if the X is not being produced, how many units of Y will be produced? Actually, this I have done. Actually, this I have done in this scenario. This I have done in the scenario I'm writing here. In the scenario, if X is not being made, but how many units of Y will be made? I have calculated these units in department A. It is 1100. Same case I will do with the Y. If Y is 0, if Y is 0, how many units of X will be made? Now I'll calculate that. Now I'll calculate that. Same formula. Same formula. 8x plus 10y means 10 into 0 equal to 11,000. So x will be 11,000 divided by 8. 11,000 divided by 8. 11,000 divided by 8. 1375. So X will be produced 1375 units if Y is not made in department A. If Y is not being produced in department A, obviously the units X will produce will be 1375. So we get to know that if we have to do it for every constant formula, that if one product is not being produced, how many units of other product will be made? Why we are calculating it? Why we are calculating it? Actually, this question we have to do on the graph. This question we have to do on the graph, like this one, right? Graph already I've told, you don't need to be worried about that, because it will not be coming as a to make the diagram or make a graph in the question. You have to understand the concept. So actually these values we are getting is actually the plot points on the graph. I'll tell how I'll tell how. For department B, same. If same scenario here, if X is 0, so y will be 10y is equal to 9,000, because X is 0. Y will be 9,000 divided by 10. We know that it will be 900 units. It will be 900 units, right? Okay. So Y will be produced 900 units if X is produced 0. Same scenario we'll do with Y. If Y is 0, then the formula will be 4X is equal to 9,000, right? So X will be 9,000 divided by 4. It will be 2250. It will be 2250 in the scenario if Y is not being produced, X will be produced 2250 as per the availability of department B's hours. Now for department C, if again X is 0, then Y will be 6Y is equal to 12,000. So Y will be 2,000. Y can be produced 2,000. Y can produce 2000 units, 2000 units here, right, for the Y. And if X is 0, sorry, if Y is 0, if Y is 0, in that scenario, the formula will be 12X is equal to 12,000 and X will be 1000, sorry, 1000 units. X will be produced 1000 units. So both scenarios we have calculated, X will be produced 1000 in this scenario and Y will be produced 2000 in this scenario. And for the demand, obviously Y is 600. Obviously for this case scenario, will not do any calculation because Y is 600. It's like in the case, obviously we are having the shortage in Y, so Y will be normally 600. You will not need to touch X in this scenario because it's only Y is equal to 600. Okay, so now we are given with the four boxes. Four boxes we are given with for department A, B, C, and demand Y. Now we have proper plotting points on graph. How will plot that? This is the point that will not come in exam, that how to plot that, because in exam it's already plotted and they can tell you to ask you to analyze it, ask you for the further calculation that we'll see in the practice. Now let's see the first point, the first box, department A. According to the first box, we have two relevant values, X 1375 units and Y 1100 units. Now I have made the graph. Just focus on it. This is the graph. If you see in the graph, one side is X, product X, and one side is Y. That was the reason I told you that only two products can be solved through linear programming, because you have to make one x-axis and one y-axis. If there are three products, where you will obviously make the line. So only two products in linear programming you can deal. So the values of units we are having was X 1375, Y 1100. We'll put it here. 1375, almost 1375, almost this point. Mm, almost almost 1375. Again, I'm not focusing on box to box and measuring very accurately. No issue, just understanding the concept. So 1375, almost this point. And on the other hand, y was 1100. So on y, it was 1100, almost between 1000 and 1200. So what we'll do, we'll match both of these points. Like it's 1375 here and 1100 here, just like that. I have made the line here for department A. Just I am mentioning here the department A values I have put on the graph and just match both of the line. Same I will do with department B. X 2250 and Y 900. 2250 means almost this point. I have written here 2250, and on the other hand 900 on Y. 900 means this point between 800 and 1000. So I'll match that as well. 2250 on X, and from here it will become almost between 1000 and 800. Almost I have marked the correct line. Now what we have to do, another line for department C. Department C, according to department C, X is 1000, Y is 2000. So Y is this 2000, this one, and X is 1000, this one. So we'll match that lines as well. Match these lines as well, like this. So we have matched all the lines we are given with in the boxes. So all the boxes are dealt except this one, Y demand box, Y is equal to 600. We'll put that value. Now you don't have any point of X here. So what you have to do, demand is 600. This is the point, Y is equal to 600, this point. So what you will do, just make a straight line here. Just make a straight line here. You don't need to like match with any X point, X line, because you don't have any X figure in this box. So for demand, if it's demand for X or Y, sometimes it's like this line. If for example he says that X is has a demand limited demand 600. So in that scenario, what you will do, you will write from here X you can't match with Y. You will make a straight line upward like this one. But in this scenario, obviously you don't have any X limited demand Y. So we have put in front of Y. Okay, this graph is being made. Now, it's the C line and it's Y demand Y line. Okay, now what we will do? Now, what we will do, I'm just zooming in the point because I want to tell you something. I want to tell you something. Now, you have how many points you are having in the region, and what is our region? Now, our considered the region that we consider is this region, the region under the lines, right? This will not be our region because it's outside the line. Our range is now this one, this range, right? Now this is our region. I am going to highlight that just for 2 minutes. This this is our region, right? Now you have to focus on this region because according to that, I am going to like tell the concept. I am just pointing out. For example, this point is I can say A. Okay, M N O. Let me use the M N O P, and it is obviously 0. So MNOP, 4 points are in our consideration. 4 points. Beyond that points, we are not focusing on these points. We are not focusing on these points. Why? Because this is obviously outside our limit. We have to focus within the limit. Now our limit of consideration, like our focus of consideration, will be only on MNOP, OMNOP. Like this is the our this is our region. Now what we have to do? Actually, what you have to do at last is to calculate maximum. If you remember, we have to calculate the best plan and maximum contribution. Okay, so what we will do here, the next step, step 5, step 4 we have done. Step 5 is draw ISO contribution line. This is the basically main step in this concept. Draw ISO contribution line. What is ISO contribution line? Actually actually ISO contribution line we have to draw in this limit. But what is ISO contribution line? ISO contribution, if you see the question, the contribution is being given to you that it's 4x plus 8y. You know that for x product the contribution is 4, and for y product the contribution is y. The ISO contribution states, the ISO contribution, just listen properly. ISO contribution states that find the point where both contribution, find the units where both contribution is same. Like in this scenario, how both contribution will be same? Both contribution will be same if for example, for we make 2 units of x and we make 1 unit of y. Only in this scenario, the contribution will be same. Why? 4 into 2, 8. And 8 into 1, 8. So what you will say that ISO contribution line will make according to 2 ratio 1. 2 ratio 1 means if you sell double units then y, double unit of x then y. In that scenario, your contribution will be same. In this scenario, if you see that if you sell 2 products and of x and 1 product of y, their contribution will remain same. Their contribution will become same. So the ratio, the ISO contribution ratio we get is 2 ratio 1. For example, just for an example, if it's like 10x and 5y, so what we'll say that we have to sell 2y, like 5 into 2, and we have to sell 1x, so that their contribution will remain same. So the ratio will be 1 ratio 2 for x and y. But here, obviously, the ratio is 2 ratio 1, that if we sell 2x and 1y, then the contribution of both will be same. This ratio is known as ISO contribution ratio. And through this ratio, we will make the ISO contribution line here. Now we are understood with the concept that in case of y is selling 1 unit and x is selling double units, 2 units, their contribution will be same. It also means that if y is sold 100 units, y is sold 100 units, and x is sold 200 units, their contribution will be same. Obviously, because double of the product y, the x is to be sold to make their both to make their contribution same, right? So what we have to do is to plot here accordingly. Now we know that if we are selling x double than y, selling X double than Y, only in that scenario, your contribution of both product will be same. So you have to just assume the point here. According to you, you can assume there is no limit in that you have to assume this. Just be focused that you are in the limit that you have told you OM and OP according to that. So if you see this point, like this is 200, this is 400, this is 600. We know that 1x and 2y is the ratio, 2x and 1y is the ratio. So if I am selling, for example, 400 units of y, just I am taking the point. If I am selling 400 units of Y, how many units of X I have to sell to make their contribution same? Obviously 800, because 400 to 800 is 2 ratio 1 for X and Y. So if 400 is Y product, is the selling units of Y, we have to match it with the double units of X. And here, when you are making the ISO contribution line, if you are considering, for example, in your exam, you assume that 200 is the unit for Y you are considering, then you will consider 400 here. No issue, no issue. You can take any unit, you can take any units of Y or X, and according to the ratio, you can make the ISO contribution line. If I have just considered 400 in Y and I know that double of that should be sold in X, that's why I've taken 800 in that. So this is ISO contribution line I had made. Now what I have to do here? Now what I have to do in this ISO contribution line? Again, I am again telling you this graph you don't need to be worried about, because in the exam you don't need to have you don't need to make the graph. He will not ask you to you make the graph. Just understand the concept. Just understand the concept. When I'll do the practice, you will say it's so easy. It's making the graph is difficult, but understanding or doing question from it will be very easy. You will see that in the questions. Now, after this process, what we will do? When we'll make the ISO contribution line, the next step is to take the line upward with the help of scale. With the help of scale, obviously you every guy has a scale. Just make the graph on the paper, put the scale here, and take the line upward. Take the line upward. Now when you'll take the line upward, more upward, obviously this line will first touch, like I will just help you like this one. Like for example, this is the point. Wait, I'm taking it upward, like as you are taking the scale in real. See, this is the line, right? This is the point. This is the point. Wait. Yes. Okay. If you take the line upward, if you take the line upward, see, I'm taking the line upward. First of all, see on the M point. See on the M point. It's like it's reached. Again, on other side, see the P point. It's reached. I'm taking it more upward. I'm taking it more upward. If you see, first which point is intersected? See, O point. If you see, the O point is intersected, is reached first. And at last you are reaching the end point. At last you are reaching the end point. So this last point is the best point for you. That is basically the point far away from the ISO contribution line. Basically, ISO contribution concept is very important. Obviously, we'll discuss further calculation in the next class, but this ISO contribution line, the far point from that ISO contribution line will be the best point you are having as the optimum production plan. We'll do in the next class for and this graph again you don't need to make. We'll do the practice for that. So this ISO contribution again, if you are selling 2 units of X and 1 unit of Y, you will be getting same contribution. This means that it is the graph, like it is the ISO contribution point that you have to plot here. In the next class, we'll focus on the next step that will have to do the calculation using this graph. Meet you guys in the next class. Till then, take care. Bye.